Okay, I think we can start. So welcome to this day two of the OAI workshop. Um, our friends are still, the crowds are trickling in little by little. I hope you slept well. The weather is much better today, which is great. So our first speaker today is going to be, first we have a different topic that we are going to start with today. Um, So, the IPR policy and the sort of the license topic is an important topic for us here at the OpenAirInterface Software Alliance. In fact, in all open source projects, it's an important topic, something that not everybody is necessarily, especially the developers, they are not necessarily conscious of, even though when they start contributing into an open source project, we always ask them to sign a contributor license agreement. So, that is where things start. So I guess, everybody is sort of aware of the fact that, when you're writing code, you are, giving away certain rights, or you're sort of, giving the open source project your code under certain conditions. So those conditions and the type of license under which the code is being distributed are very important topics in open source. And we are very lucky because we have over here Dave, who's really an expert at this subject. So Dave is the Vice President and Legal Counsel at Qualcomm Technologies, where he's currently leading open source practice and policy team. Dave's background is in the fields of technology transfer and community licensing practices, and he has been involved in open source for a long time. One other important topic that we deal with is how standardization and open source link to each other, and Dave is going to speak about that topic also today. Dave, welcome.
So thank you for that. Thank you for that very kind introduction. And I was reflecting on the drive in this morning how long I actually had been practicing in this space. And I remember it was in the .com days, if you guys remember that. It was like I was in a startup company, and it was late at night. I was trying to go home, and the engineer walks into my office and says, "Take a look at this license." It was the GPL, okay, GPL v2, and I was like, "What is this thing?" I'm tired, and it was like, I was just trying to just sort of resolve the issue quickly. Can we use this code or not? This thing that they wanted to standardize on, for the app, called something called Linux. And I'm like, okay. And then it was really like, it took about an hour and a half before I slogged my way through that license just to get to an answer that, like a very short answer. And my answer was no. My answer was no, we can't use this stuff. I understand this license, first of all. And second of all, it looks like it's going to, create some obligations upon us. But eventually, I became comfortable with it. There's a lot of industry practice in this space that actually, once you get into it, you find other ways where, maybe the situation is not quite as bad as you think. But yeah, that was, so that was 24 years ago for me. And it's been a really interesting journey. It's no longer the same space. Back then, it was kind of a bunch of pioneers. There was a strong sense of altruism at the time. It's like, I'm going to write this code. I'm going to, donate it to the world. For the most part, a lot of these people were not getting paid. They had the skills. They just weren't getting paid for it. Today, it's a very different space. It's a very different space in the sense that you have these, these valuable skills, are now getting, for the most part, well compensated, and working for companies, and strategically engaged by those companies in certain coding activities that benefit the company. Now, to me, that comes full circle as to sort of a proper landing place for this whole thing, because this is rational self-interest, at different levels, ultimately to try to make a commercial living. in this space. But there is still, some sense of altruism, about this thing, and that's really a very cool thing. But when we're talking about open source and standards, you're talking about two communities that are driven to do really two fundamentally different things. Okay, so they have distinct roles between open source and standards. So with open source, a lot of times it's like, kind of, it's a little bit like scratching your own itch. It's like not quite, let's say, what it was in the old days, but companies have certain reasons why they deem certain projects as key dependencies for their commercial objectives. And so what you end up doing is kind of like how Arpit yesterday was talking about the plumbing. This is about making sure that the plumbing together is fundamentally working. And then later companies can differentiate on top of that stuff and create product differentiation to maximize their space. But the point is, you're working basically on a canonical set of plumbing. That singular set of code is intended for a canonical use case, an implementation, if you will. And everybody is supposed to glom onto that thing and build basically, and that's the vertical dimension you see on this chart. That's the vertical dimension where we're really trying to build all together something that's going to work. And you have the right under open source licenses to fork. You have the right to be able to sort of go your own way, those little, small horizontal arrows. You can create your own competing project, and sometimes that's been done. But I can say every time that I've seen that done, it has been viewed as somewhat anti-community. And the reason why is, very understandable. It creates, a sense that why didn't, these folks want to stick around and work with us? Was there something about their engagement, something about the roadmap, something about the vision that wasn't lining up, or were they not being heard? But objectively, it also just, frankly, it dilutes the energy. It takes the attention away from, the canonical project, and you end up potentially creating some barriers to entry. New people like, do I contribute to this one or this one prime? So you have that ability, but when exercised, it sometimes leads to some question of why that happened. And then in the standard space, it's very different, right? You create a specification, and that specification is published or accessible or given to people, and that specification becomes that common thread that allows competing implementations. And you want competing implementations. That is the characteristics that you want in the standard space, and that creates the resiliency and the diversity in that space. So if one implementation, let's say, is not very good, you have other choices, and there's competition in that sense. So what you have is you have two systems doing two different things, and ultimately, there it is. Ultimately, this is a relationship with each other that's very complementary. In other words, they're not replacements for each other. They're actually two systems that ought to work well with each other because of their different objectives. Now, how does this actually look within a broader ecosystem? So this is about the public-private partnership we have between both standards and open source, and what's happening sort of in the open, in the public, and what's happening in private. Okay, so if I start, and public is on the top, private is kind of the greenish thing on the bottom, and then there's two things also on top. There's something that's happening inside of a standards body, and there's stuff that's happening outside of a standards body, but still public. And that's the open source piece on the right there. So let's start from the top left. So you have the standards activity happening. The standards folks are building their specification. And at some point, there might be an interest in doing some software work. What could that be? It could be proof of concept. It could be sample code. It could be even snippets. Maybe it's something that could be, used as something, for future normative purposes. It could be test suites, test harnesses. It could be even pilot implementations. But those kinds of things happening inside, I'll use a pointer from here. So So those kinds of things happening in the software sense inside the SDO, of course, it needs to follow, the same IPR framework as the SDO. Now, the question is, as it starts to interact and with outside the SDO world over here, so you can have things that might actually feed over here, and you can have things that might come back into the software project inside the SDO. I feel like I'm losing the mic when I turn my head. Salvina. But what's happening here is you have let's say, in order to build this project here, you have, I'm okay, thanks. Yeah, thanks, they're fine. Of course, nobody writes software from scratch anymore, right? So, it's like 80% open source. And so what you have is, you have software coming in order to build the SDO software. And then what comes out? Well, you could have the whole thing come back out, or you could have certain things that are more like essential enabling bits. Let's say ASN1 files, Yang models, other things could be coming out with intentionality to enable the adoption process for those standards. But ultimately, you have these external open source projects. Think of, OAI. So these external open source projects also need to be working on code. And these could be full-on reference implementations. They could be something less than that, but they could be different things as well. And then those things end up being the things where you ultimately have developers, oftentimes developers paid by commercial companies, working on things to build something that could be of financial interest down the road. But those projects end up naturally coming into these commercial product sales that end up ultimately, when successful, paying FRAND royalties back to the standards contributor, and ideally it goes back up over here to fund further R&D on the next version of the standard. So that would be, the cycle that would describe that we want to encourage. If we have these external open source projects that are going into commercial product sales over here, think of this as something in the order of like 80%. Okay, you hear different numbers, but 80% plus or minus, a few percentage points, you're not going to be that far off in terms of how much open source is in a typical commercial product today. Yeah.
Dollars are related to the intellectual property.
Yes, yeah, this is related to intellectual property. Yes. Let me talk about that a bit more. Okay. So when I talk about this piece down here, this is on the patent side. These are FRAND royalties. Okay. Over here, these are mostly on the copyright side. Okay. Or the rights you get under whatever open source license is selected down here. And there's also a license over here. We can talk about that too. Does that make sense? Thanks. And please do, I can't quite see all the hands, but if you, call out, raise your hand, I'll try to spot you, and we can take questions as we go for sure.
One quick question.
Yes.
SPO software, I'm trying to compute that. Is it inside the SPO, or SPO is only generating software and they are producing documents and the software is private by it? I'm trying to understand.
Yes. Thank you for that question. It's a great question. So are standards organizations actually developing software today? In some cases, yes.
Mm-hmm.
Yeah. Are they producing like full-on reference implementations? In most cases, no. But there have been a couple cases where that has happened. And that kind of goes back to this slide over here, okay? Where I'm trying to say, can standards organizations, do some vertical work? Yes, they can. It's questionable whether or not that's the best thing for them to be doing, because their job, I think, in my opinion, is about enabling the more horizontal stuff. But that hasn't stopped some standards organizations from sort of feeling some pressure to do some more. And sometimes that's going to be more about enabling and streamlining the adoption process, giving some tools out so that people have some additional sort of common pieces in order to accelerate their process of developing their own implementations. Sometimes they can be more than that. Yeah, great question. Thank you for that. No more questions for now. So, so let me go to the next slide. So think of a metaphor that I'll use for a moment. So if the SDO is sort of an accumulation of, let's say, the experts in a given field, let's say what we're trying to do is collect all the best chefs in the world and put them into a room. And their job is to build the best possible recipe for vanilla cake. And this vanilla cake thing is going to be, it's going to have all the details, in the recipe as to exactly how it's going to be built. But then when it comes, sort of down the road to the folks that are implementing the stuff and actually, the kitchen, if you will, where the cake is actually getting baked, there's sometimes a lot of times there's additional detail that, people find is missing from the standard. And so there's going to be on-the-fly innovation. There's going to be, additional enabling tools that will have to get developed on the fly as well. So that improvisation, those implementations, sometimes there's significant research also happening in that space, especially if you get into a unique vertical that has different environmental variables that's different than what was assumed during the standards process. So ideally, you would have basically a framework that allows the people that were building the standard to also go into the kitchen, if you will, and help bake the cake. So I think I mixed my metaphors there, but anyway, so you have both activities happening, and you want to be able to leverage the expertise of the people that are upstream into informing the people that are working downstream. If you have a process where the people that are working upstream cannot feasibly enter the kitchen down the road and actually work on the implementation work, that can create dyssynergy. So in an optimal way, how might sort of concurrent activities in this sense complement each other? Well, let's start from the left side of this chart, okay? On the y-axis, you have the percent of effort, let's say, for a given activity. And the blue line is going to be the standards activity, where in the beginning on this chart, it's going to be, let's say, already at 100%. Everybody's working on the standard. And in the orange line, that's going to be the software work, okay? And let's say this is a reference implementation, just to sort of underscore the idea that there's good things that are found out in the field during the implementation building process that could potentially feed back into the standard. But in the beginning, until you actually have until you have enough to be able to start writing code off of, you don't have any software work happening on the reference implementation. When it gets baked enough, where on the standard side, where you can actually start writing code, then you'll start to see that come up a little bit here, okay? And that's the start of the reference implementation. And then eventually, the reference implementation is working full speed. And ideally, if these are two systems that are working together compatibly under the same IP mode, guess what? The reference implementation work can potentially inform and make the standards work better. So when it's concurrent like that, we think that this is a nice outcome for a cohesive ecosystem. And then as you move to the right, what happens is the standards work starts to wind down, signals to the marketplace, this is a complete standard, this version is baked, it's ready to go. Meanwhile, the open source reference implementation work, in this sense, this will have to continue, it's catching up. And at some point, that too will start to taper. It never goes down to zero because it's software, right? Software, you always have to have, maintenance, there's bugs, there's other things that have to be enhanced. So it winds down to a degree. At some point also, the standards activity, starts to kick back up for the next version. And then the reference implementation work, then builds on top, assuming that there's common code that can be used from the first version to the second version. So to me, that's a model where if you have the right conditions set, both the standards creation process and the code development process can each make each other better. All right, so how can this go wrong? So how to create dyssynergy? I had to hyphenate that because apparently dyssynergy is a medical term, then I didn't want to use that. when the parts of the body don't talk to each other. In any case, so when you have, an upstream and downstream regime that are not compatible with each other, you end up prevent's probably too strong a word. You make it too expensive. You make it too expensive for the people that are upstream from being able to enter the room downstream, okay? Because there's a bunch of investments in the research that were contributed into the standard, and if they were to give up on any return on investment for that research, that ends up taking them out of the game for any future version of the scientific research in that area. So basically, it kind of exits them from that space because there's no more return on investment through the FRAND framework. It also makes it more difficult for downstream creators from making investments themselves. As Ed talked about yesterday, he gave an example of these drones that would identify, here's a weed, and I'm going to, put the herbicide right on that weed, and I'm going to keep on flying, look for the next weed. There's a lot of technology that has to go into that, for that specific use case. There has to be a lot of research that goes into that, and unless there's something that's, say, funded from public money, it's hard to imagine that a commercial company would actually invest in the science on that and then donate those pieces to open source and their nearest competitor. It just wouldn't make economic sense. But if you want the very best to actually go to the community, the FRAND promise actually allows you to do at least a significant part of that, because by that, the best can get contributed because the return on investment isn't based on the open source piece. The return on investment is based on the return on investment for the scientific research under FRAND. Field trials can be expensive. And sometimes you need someone to actually build those common pieces as well. The plumbing that we talked about before, sometimes the plumbing is not enough by itself. Sometimes you need to have additional tooling, test harnesses, and that can actually be sometimes harder than it might appear. So if we adopt sort of a narrow definition of open source that ends up creating a conflict with the standards development policy upstream, that can be one way that this synergy can be created here. So I don't want to get all the way down this rabbit hole of all these different licenses, but I do feel like I need to talk about a few of them, okay? Because when I start talking about the OAI license, I do want to draw some contrast with, between how the OAI license is slightly different than some of these other licenses that we see out in the open source space. But just the takeaway on this slide is that it's a gradient, okay? You have the GNU GPL that we all know, it's the license I talked about in the beginning. It's a license that is worth reading a number of different times to really appreciate it. But it's a license that has a copyleft thing, and it has, the most recent version has a patent provision, but it's considered to be somewhat restrictive because it has a number of obligations that some companies find, not that easy to deal with. I think those issues are actually less than super difficult if you have a process to be able to deal with architectural issues. But it is a process that actually requires overhead. All the way on the right side of this slide, you have the more permissive licenses, MIT, BSD, and these are very short form licenses, right? These are just licenses that are literally written on a piece of scratch paper and then said, this is the license. In fact, that's the narrative that you'll hear from Bill Joy, who wrote the BSD license when he was I think by then, I think he was an employee at UC Berkeley. Similarly with MIT, but these are licenses, and Berkeley and MIT have said, they intend those licenses to be copyright only licenses. Other people want to ascribe, additional meaning to those licenses, but the copyright authors, the universities, don't consider those to be anything more than copyright licenses. In the middle here, you have Apache. Apache is a license that's actually very useful for some cases. It's not useful for all cases. But if you're on the pure consuming side and all you want to do is get maximal rights, even if you're not quite sure what all those are from the people that live upstream, Apache is not a bad way to go. But the problem is the Apache license, when you're talking about a ecosystem that is based and sitting downstream from a standards-based IPR policy, it actually creates a whole nother layer of complexity in an area where you actually want clarity as much as possible. Because when you have these rights holders that are sitting upstream and they've given FRAND obligations on their standard essential patents, when you put in something downstream that says, oh, if you walk in the door here, everything has to be royalty free, that creates a significant impediment on their ability to even assist in the downstream work. So there's other things in the Apache 2 license that is, probably inconsistent with the SDO IPR policy that might prevent code under Apache 2 from being able to be consumed upstream. So let's say you discover that this is really great stuff. We've defined an even better, more efficient API down here, and we want to upstream that in the form of code snippets back into the standard. You may not be able to do that. The standard may not be able to accept that code and under its policy. And then there's an ambiguity in the Apache 2 license around what the term work is. So there's a concept there where you're giving a royalty-free license for not just your contribution, the claim to infringe by contribution, but also in combination with other stuff that is part of the work.
So that would mean prior work as well.
So Irfan asks, would that mean prior work as well? Great question, because the work is not defined anywhere except that it's something that's copyrightable. Okay. I have a slide that actually I included here, but I probably won't go into it because it's more, of academic interest for lawyers. But the question is, if I contribute this piece of, this patch to this file, and this file is sitting under this branch, am I granting a patent license to the stuff that's, infringed by this file, this branch, this subsystem, the project itself, well, what if there's, the project that's being run by this entity, and then there's other projects over there. Am I looking at all those projects as well? What am I granting my license to? And the problem with software in this sense is that unless you actually provide like the metes and bounds, telling an engineer to go write me a specification for all that stuff that might be out there in the sense of what is a work. That's not a fun task for any engineer, for any person, and because the boundaries are so unclear. So what you have is this boundary where it's really hard to determine, and unless the project itself comes out and says this is what I mean by work, which is rare, you end up with this persistent ambiguity. And then also when you're building a project, let's say there's oftentimes this idea that more functionality, the functionality gets broader and broader, and that gets added on. And as it gets added on, who's writing the updated specification? Because now that the engineer spent a month and a half writing the specification for what is being, but by the way, why do we need a spec? Because you need a spec that has a functional description in order to actually run the patent search to understand what's being infringed. Okay, so that's why. So then it updates, and nobody's updating the spec. It's all manual. It's really difficult, and it ends up running counter to the objective to try to create code quickly. Let me pause there with any questions. Okay, all right. This is the slide that I'm going to skip. I'll circulate it with the slides. But it's like, what is a work? At what level? Coming to OAI specifically. So OAI, and Irfan, sorry, without permission, I took this snapshot, the screenshot from our website. I should have an attribution statement there if I was actually a good lawyer. But basically, I added these orange arrows, and the OAI software licenses basically are twofold. One is, there's the 3-clause BSD, which I already talked about, and then the OAI public license version 1.1. So this license is a license that, if I tell you that, hey, this thing is derived off of the Apache license, you might be like, well, you just said the Apache license had all these problems. How is this a good thing? Let me explain. So the OAI license, OAI public license 1.1 has a concept, that basically takes FRAND and adds additional obligations on top of it. Okay, So it doesn't like sort of grab, the whole thing and, throw it out and replace it with something completely different. It says, okay, we've got this FRAND thing, that we inherit from, from in OAI sense, 3GPP. How can we actually build upon that to add additional provisions that protect the software space in the context of the software development activity? And the way that it's done is the contributors, they agree to license their essential patents on a royalty-free basis first for study, testing, and research purposes. Okay, so that's kind of just an easy one, right? Just that should just always be enabled. And then second, on top of that, okay. I should explain what essential patents are. Essential patents are all the claims infringed by not just the stuff that is essential to the standard, but also everything infringed by the code base itself. What does that mean? All right, so you have all this other enabling code, you have all this other, all the other subsystems that are running underneath in order to build that feature set. All that other stuff, that's part of the OAI code base. All that other stuff also benefits from additional FRAND promises when one makes a contribution, and the read is based on the combination claims. So that is an additional, fairly broad obligation from contributors to prevent the whole concept of, and some people say that hold up on patents is a real thing. Some people argue that it's not. However you land on that, in the case for the OAI public license, it solves for that by making sure that there's a FRAND promise that goes across all, everything across the board for those combination claims infringed by a contribution. Okay, so that's, that goes across the OAI project itself. So then, so that's a layer on top that doesn't create the incompatibility that sits on top of the 3GPP obligations that we inherit. And then the OAI contributor license agreements. Those are all consistent. Sometimes you run into an open source project and it's like, well, our license is this, but then you have to sign this, CLA, and the CLA says this and this and this and this, and then so there's consistency across both the license and the framework for OAI. No surprises there.
Does that mean that this comes as a package to license from the CLAs, while for other cases, for example, for BSP, there is no standard CLA? Does it mean that?
Yeah. So the question is, it's a package, in the OAI sense, CLA with the license. But if there's a project that's under BST, how does that actually work? And the answer is, it's all over the map. It's all over the map outside of OAI. Okay. I think if you went back 24 years when I first started in the space, and I'm not the first, okay, it's, Stallman wrote his license, I think back in 91, at least the first version. But, if you go back in time, you would see basically just practices just sort of across the board, and over time, and through good governance, okay, as that has evolved, you've seen more contributor agreements. You've also seen the rise of this thing called the DCO. DCO, it stands for I forgot. Thank you. Developer Certificate of Origin. Thank you, Jimmy. And so the DCO, it's kind of this recursive thing that says, I have all the rights to, I either wrote the code or have rights from people upstream from me that to give this code under this license. In that sense, it's not a contributor license agreement, because it's basically just taking the concept that some folks like, which is a pure inbound equals outbound concept, where the rights that come in is under the license and just that license ideally, and then the rights that are outbound are just under license. That is, I think that's a fine model for a lot of projects. For a project that actually wants to have some flexibility down the road, if one wanted to be able to, let's say, consider other licenses, having a contributor license agreement that has those kinds of flexible terms is of a benefit. And you'll see more centrally managed projects end up using contributor license agreements. And you'll find an equal number of people that just abhorrently dislike them. As a lawyer, I tend to like them. And so, because I have a good understanding of what that means then, but there's different opinions out there. Pausing, any more questions? Okay. All right, so, how am I doing on time? Oh, I should be right. Okay, so I'm gonna be wrapping up, sort of on this trajectory. So, what is the advantage for OAI here? Well, I could go back to this diagram. We avoid the bottlenecking where we end up titrating out some of the participants upstream from the external open source projects. So we avoid this. Is it happening? Now it's happening. We avoid this where you have all this stuff that's happening upstream, and then you end up narrowing down the funnel so that only a few of the upstream contributors, can contribute to the external open source projects downstream here at OAI. Avoiding that, and then you end up with that. Yeah, I did those animations myself. So you have these upstream contributors, it's much broader, all coming down, okay? And you have these, you have broader participation then in OAI. So takeaways. So look for compatibility opportunities, upstream and downstream. Try to not introduce something completely new downstream, especially in the context here, okay? Apache 2 license stuff, it has its place in the world. But in the standard-centric coding project, when you're trying to inherit as much knowledge from the researchers that actually help build the standard, don't try to re-articulate the fundamental framework. By doing this, you allow the ecosystem to operate really as intended. You have the broad activity that's happening on the standards horizontally, and you have the open source thing happening vertically. You have a multilateral way to grow the ecosystem. And by doing that, each can be the best without diminishing the other. I try to avoid the religious debates, but I can have them if that's something that people feel is productive. But ultimately, with the OAI project and the license and the framework, what it does really well, it allows all the interested participants to just focus on the code. And that's all I have. Thank you.